Hello everyone, in my last video I taught you how to solve basic linear equations. But what what if I told you that there is an easier way to solve these? So for this, right? How do we solve this shit? This is literal. Okay, pause. So the definition is that a plus a times x plus y equals to ax plus ay. For example, 4 times bracket 5 plus 2 bracket. There's two ways to solve this. Either you multiply using the distributive property, or you add up the numbers before you actually start multiplying. And both of these lead to the same answer, unless there is some part of the equation that makes this not commutative. Commutation is basically asking, will I get the same result if I switch the numbers around? Yeah. So as you can see here, we can use the distributive property to find this. We bring the x into the 2, which gives us 2x, and then the x gives us this, giving us x squared, or x times x. And notice that we have 2 x's, which means x squared. And the reason this is x squared is because we actually use this. This is used a lot in finding the area of a square. Then we subtract 2x from both sides. The 2x's cancel each other out. And then from here, we square root both sides. So the square root and the square cancels out, and the square root of 9 is just 3. So therefore, x is equals to 3. Now what about factorization? Now, I know this is challenging. Factorization is kind of a big word, but essentially it's basically like expansion or the distributive property, but the other way around. So we have to find the lowest, so the common whatever of the thing. So first, we see that 15 and 9 share a common multiple of 3. So we just express that as 3 times 5pq squared minus 3p squared q is equal to 0. And then from here we get 5. And then from here we can factor out p, and then yeah. And then from here, we get q, which ultimately gives us 3pq bracket 5q minus 3p bracket equals to 0. And there's no way we can solve this, or the 0 is kind of useless. So basically, the factorized form of 15pq squared minus 9p squared q is equal to 3pq bracket 5q minus 3p bracket. Okay, now, how do we factorize this? Well, it's easy. You just gotta factor out x squared from both sides, leaving us with x squared bracket x plus 3. Yeah, so this is an example of the distributive property and solving basic quadratic equations. Now now we're gonna move on to solving for quadratic functions. And this is actually a very long section because there's a lots of algebraic identities that you need to be aware of. But I'm gonna try to simplify them. Okay, so first up, we already learned about the square root function, so I'm just gonna not touch on that anymore. What you may not have known is that the square of a sum of a binomial, which is a sum, is we can express this as bracket a plus b bracket a plus b, giving us this. And then from here we can just use the distributive property. And then we can simplify like terms. So therefore, bracket a plus b bracket squared is equal to a squared plus 2ab plus b squared. Now, when would this be useful? This is actually pretty useful in mental sums. For example, 397 times 403. Wait, no, I just realized. Ah, shit. Okay. Okay, so we have to solve these equations, right? This equation, right? So we gotta use this property right here, and this becomes 3 squared plus 3x plus x squared equals to 9, and then 9 plus 6x plus, oh my god, 6x plus x squared equals to 9, and then we cancel out x from both sides, leaving us with 0. And then we can factor this out to become x bracket 6 plus x bracket. And then we can divide by x, which just leaves 0. And then we subtract x from both sides. Then we subtract 6 from both sides, sorry. Leaving us with x equals to negative 6. Wait, what? Let me check if this is correct. Yeah, so I got one of the answers correct. Now there is a much easier way to do this. We can just square root both sides, leaving us with x plus 3 equals to 3. And then subtracting 3 gives us 0. So x is equals to 0, x equals to 6. Therefore, x equals to negative 3 plus minus 3. we use a plus minus because the first term is the midpoint of 0 and 6, and the second term is basically the difference between both of those between the start and the midpoint, and the midpoint between the midpoint and the endpoint. Alright, now a minus b squared equals to a minus b bracket a minus b, giving us with a bracket a minus b minus b a minus b, giving us a squared minus ab, and then the minus ab minus b squared, yeah, and then the negatives cancel out, giving us b squared, and then we simplify like terms to give us minus 2ab. And notice it's actually pretty similar, the only difference is the plus. So a plus minus b is equals to a squared plus minus 2ab plus b squared. Okay. Now here's like another law or something. Apparently bracket a minus b, a squared minus b squared equals to a minus b bracket a plus b. And a squared plus b squared, you can just think of it as a squared minus b minus b squared. Now, there is a difference between the square of negative b and the negative of b squared. The difference is that the square of negative b equals to negative b times negative b. The negative cancel out, leaving us with a positive. However, a negative of a square is equal to a negative of a positive times a positive, which still gives us a negative in the end. For this case, this is the negative of a square. So yeah, this just gives us of a minus b, a plus b minus b bracket a plus minus b. What? Minus what? How does that even happen? What even is that? What? Now this is useful when you're doing like mental sums. For example, 160,000 minus 36. 160,000 minus 36. Wait, no, let me make it more challenging for you. We can express this as 400 plus 6. Wait, no, let me make it more challenging for you. There we go. We can express this as 400 plus 6, 400 minus 6. And this will give us with 400 minus 6 squared, leaving us with 16,000 minus 36. Which will give us approximately 159,964. So that is the answer. And this is so as you can see, the difference of squares formula can actually be pretty helpful while you're doing like mental sums. Oh no, by the way, I'm kinda sorry. I just yeah. But now we have to solve intermediate quadratic equations. But don't worry, I'll simplify it to you step by step. This is going to be a very long proof. So, a 4. So if I'm not wrong, this means that we subtract C on both sides, leaving us with this shit. And then we times 4A on both sides. What? Wait, I feel like I'm missing something here. What? Oh, right, I forgot. We multiply by 4A, not 4. Wait. Oh yeah, that's correct. And then I think we can as 2ax bracket squared, since the square root of 2 is of 4 is 2, the square root of a squared and x squared is ax, and 2 and then wait, is that correct? Yeah, I think so. And then we express this as a difference of squares, giving us bracket 2 b equals, and then yeah, I think that's about it. Minus 4ac, then 2ax plus b equals to plus minus square root of minus 4ac wait, no, I feel like I'm missing something. Whatever, it's fine. And then I think we subtract b on both sides, giving us this shit. And then this leads us to the final formula known as the quadratic equation. X is equal to negative b plus or minus the square root of b squared minus 4ac and divide it all by 2a. That is the quadratic equation. I'm terrified that I remember all this. Well, I think I remember almost all of it, except for this part right here. I can't seem to figure it out, but other than that, I remember almost all of it. And I am terrified. So I think this is the quadratic formula and the full workings behind it. So yeah. Let's look at some examples. Let's look at one example. For example, 6x squared plus 8x plus 10 equals to 0. And then we apply this formula right here. We label the coefficients A, B, and C. So this is negative 8. This would be 8 squared minus 4, 6 times 10 over 2, all over 2 times 6. This gives us 12. And then this gives us 64. Then 4 times 6 is 24. Then times 10 equals to 240. And then this becomes 64 minus equals to 24 minus 200. That's negative 176. And then I think we can simplify the roots. You have to trust me on this one because I haven't really introduced to you on that one. You have to trust me for this one. And then we divide all by 12, giving us negative 2/3 plus minus the square root of negative 11 over 4 divided by, that's 3, right? Yeah. So yeah, this is the solution for this equation. And notice that we use a plus minus symbol here because this is a square, which means two things. A positive times a positive equals a positive, and a negative times negative also equals a positive. So we have to put a plus minus here. In short, a plus minus basically means it's true for both positive and negative values. But there's one very important step that I am forgetting, and that is this shit over here. This is actually really advanced. So this becomes cx dx plus b plus a dx plus b. And then this gives us a cdx squared plus cxb plus a dx plus ab. Now, is there? I think there's something that we can factorize. I think, I don't know, man. It's x 80 plus bc x times and yeah, that's pretty much it. I think I'm going to lose my mind. Alright. I think that's the end of lesson 2. Thank you very much for watching. And I'll see you later. And no, I will not talk about inequalities. I absolutely hate them. And plus, you can just research them. Alright, bye.